Welcome to my third video outlining my software as a service or SaaS project. In today's video, I will talk about why I chose onion architecture and domain-driven design. In the last video, I talked through how I took a paper-based process and started building a multi-tenant SaaS platform to handle package logging. Today, we're going to dive into the architecture behind the project, and specifically why I chose onion architecture and domain-driven design to guide my development. If you've ever struggled with keeping your code base flexible as your app grows, or you've hit walls trying to maintain a clean separation between the core business logic and infrastructure, then hopefully this video will be for you. In this video, I will discuss how onion architecture and domain-driven design, DDD for short, can help solve those challenges, making your application easier to scale and maintain, and how it helped me rapidly build in a few months the beginning of my platform. So what is onion architecture? Well, it's about ensuring a clean separation between the different layers of an application, of which the domain model forms the core. Onion architecture separates the layers with the domain model at the center and the presentation layer on the outside. So all the dependencies flow inward, with the inner layers having no knowledge of the outer layers. This provides a flexible, sustainable and portable architecture. For example, the UI or database can be switched out easily for another. The different layers give us separation of concerns. This is one of the fundamental principles of software development. The idea is to reduce coupling and increase cohesion. In simple terms, cohesion is a group of relevant stuff, so methods and classes whose duties are similar, that they can belong to the same class or namespace. For example, if we had two methods, draw circle and draw triangle, we will put these methods close together in the code base. They're similar enough that they will belong together, and we will consider these highly cohesive. Coupling we would measure by its dependence on the rest of the system. For example, if we didn't use a repository to abstract away our data access code via an interface, and instead we just used a concrete class that interacted directly with a SQL Server database, we will consider this part of the system tightly coupled to the persistence layer. Changing to a new database would be difficult. Same applies to code, where we tightly couple ourselves to an implementation of something. That something could be a service or a layer in architecture, such as presentation layer, communicating directly with persistence layer. We get better maintainability as all the dependencies flow inwards. To allow for this separation, we rely on interfaces and abstractions between the layers, allowing us to easily write unit and integration tests. That ensures that we have a regression suite of tests that we can run at any point in time, and that'll give us confidence in our code base. Finally, frameworks and technology can easily be changed without impacting the core domain. I can replace SQL Server with a NoSQL offering. I can use both SQL and NoSQL. I can replace the front end with React or Vue. In fact, my hope is to create a React site that will be used by the residents of the building. That will have different use cases. Plus, gives me an excuse to learn React on a real world application. So what are the layers? The domain layer contains the entities, value objects, and stateless business logic services that don't fit in the entities or value objects. A stateless business logic service encapsulates business logic and rules without maintaining any state between the method calls. And these are created when these functions don't naturally sit on an entity or value object. For example, at some point I will need a pricing engine, so my tenant each month can be billed for the modules that they subscribe to. A subscription pricing service will take the tenant in the subscription billing object, apply some rules such as adding taxes, and then return the calculated cost. All this takes are inputs and outputs, and this functionality wouldn't necessarily fit on either the tenant entity or billing entity. This way we maintain separation of concerns, don't violate the single responsibility principle. This also makes our domain model more maintainable and testable, as these business rules can evolve independently of the underlying entities. As you can see, these all reside at the centre of the architecture pattern. The application services layer, you see in yellow, sits outside the domain layer, and this is where the contracts for services and repositories reside, along with any DTOs, data transfer objects that we would need. These services tend to be used for orchestration and shouldn't contain any business logic. They will also only depend on domain interfaces and abstractions. So an example would be if a resident requests to pick up a package, an application service might coordinate between a resident service, a package service, and then perform an authorization check to ensure that the package belongs to the correct resident. However, the actual rule, such as whether the resident is allowed to collect a package on behalf of another resident, will belong in a domain service. Outside of the application services layer, we have the infrastructure layer, in green. It is here that we would have our repository and service implementations of the interfaces that we defined in the app services layer, along with any data context that we might need. Any services that interact with external systems such as APIs will have concrete implementations in this layer. And then, so keeping this logic in the infrastructure layer ensures that the core domain remains independent of external dependencies. This means that if I need to swap out SQL Server for a NoSQL database, integrate with a different payment provider, I only need to change this layer. And I'll leave my domain logic untouched. And finally, we have the application. Application. Finally, we have the application and presentation layer. Our front ends reside within this layer, console applications, things like that. This is where user interactions happen, whether it's through an Angular web application, a React front end for residents, or even a mobile app. The goal is that regardless of how users interact with the system, the underlying domain and application layers remain consistent and stable. So now that we've gotten that out of the way, what exactly is domain-driven design? DDD for short, it is an approach to software development that prioritizes modeling the real-world domain that the software serves instead of starting with technical concerns like databases or frameworks. DDD focuses on business rules, behaviors, and workflows that define the problem space. By structuring the application around the domain, the code reflects real-world business concepts, making it easier to maintain and extend as the business evolves. So we think of the domain as a sphere of knowledge that we're trying to model in software. One of the biggest benefits of DDD is the use of ubiquitous language. This is a shared vocabulary used across developers, domain experts, stakeholders, and testers. So instead of technical jargon, everyone speaks in business terms, ensuring alignment between code, documentation, and discussions. This helps to reduce misunderstandings and makes it easier for non-technical stakeholders to contribute leading to better requirements. It also helps us to encapsulate business logic in all the right places, where it's encouraged to replace the core business rules with entities, value objects, and domain services instead of having it scattered across presentation layers, database layers, and any other layers in between. Doing so should help to improve maintainability while reducing duplication of rules across the digital estate. DDD will help us to reduce coupling and increase modularity by separating out our business logic from our infrastructure concerns, such as databases and APIs, and we're more able to swap out technologies without breaking that domain model. In large applications, trying to use a single domain model for everything can lead to conflicting definitions, bloated models, and unnecessary complexity. Instead, DDD encourages breaking down the system into multiple smaller models, each with a clear ownership and a well-defined boundary. And these are called bounded contexts. A bounded context defines a logical boundary where a specific domain model and business rules apply consistently. Each context has its own terminology, rules, and understanding of a domain. Different contexts do not share models directly, but instead communicate through APIs, domain events, and messaging systems. That maintains the separation and prevents tight coupling. So if we took an e-commerce platform as an example, in the customer context, an order will include details like discounts, payment information, and order tracking, reflecting how the customer interacts with their purchase. But in the context of a warehouse, an order represents a shipment, probably contains information about storage location, dispatch times, and handling requirements. It's still got the same high-level concept of an order, but each bounded context has its own interpretation, model, and rules based on its responsibilities. Within a bounded context, we will deal with groups of related objects that should be treated as a single unit, and this is where aggregates come into play. An aggregate is a cluster of domain objects that belong together and must be kept consistent. And at the core of an aggregate is the aggregate root, which acts as the only entry point for managing its internal state and enforcing business rules. So I'm just going to switch to Miro. So this is my relational model. More reflects a relational model. And if we focus on packages, I can see how aggregates apply. So a package isn't just an isolated record, it's connected to a resident, and the apartment, so the dwelling. It's connected to a site, and through that its tenant, along with the user who logged it. And if I wanted to retrieve a package and all its relevant details, I wouldn't reach directly into multiple services. Instead, I would go through the package aggregate, which manages these relationships and ensures consistency. No other aggregate in the system can modify these connections directly. Everything must be done through the package aggregate, and this keeps the business rules intact and prevents inconsistencies across the system. I have more of a theoretical domain model, I guess. So you have package, concierges. Well, it's still more relational. Okay. As you can see, onion architecture and domain-driven design complement each other and enable evolutionary enterprise systems to be developed whilst increasing code quality and reducing complexity. Hopefully it's become clear why I chose it for my project, but here's a quick recap. By isolating business logic from infrastructure, I can test core features without worrying about external dependencies. This is achieved by coding against abstractions and the inner layers. The layered approach to running architecture makes it easier to scale the app without creating a tangled mess of dependencies. When I add new features or integrate third-party services, the core business logic remains untouched. And lastly, maintainability. As the project grows, I can swap out outer layers, such as the database or the UI, without affecting the inner layers. And now that I've explained the concepts behind onion architecture and domain-driven design, let's see how this applies in the actual code base. And seeing it in practice should help make these ideas a little clearer. So, I'm going to show two APIs. So as you can see, I've got the domain, infrastructure, applicant services layer API, along with some tests. And same goes for the users as well. Or the API if I didn't show it. On my business roles, and there's not much at the moment, just my entities. In this, just have my entities. But by keeping everything in the domain layer, that separation affects any changes in my UI or database. I'm protected from outside interference. And then we have my application layer. So, as mentioned, contains my DTOs and my interface for my repository. And if I switch over to my API, again, you will see I have my DTOs and I've got my repositories. Again, only abstractions. Shows me interface. Family interface. And then we have my infrastructure layers. So here we have the concrete implementation of my users repository. And that is my user context. Also have my database migrations. In this layer, if I switch to my tenant API, you can see again, I have my context, I have my concrete implementations on my interface from the services layer, and I'm the database migrations. So is the I just want to try and tie that together for you. So the application layer my API. And I have in here again, services. But these are the services that are only specific to the application. So inside these, taking my repository, which is the abstraction, and all this does, I can provide at runtime any implementation I want for this, which I do in my tests. I'm able to test my repository, my services, and I'll provide a test repository. So as you can see, I'm only coding to abstractions. There's abstractions here. And if I switch to this one, I have similar here, services. Not that one. Again, you see, I'm just because this uses ASP.NET identity, it's slightly different for me. I'm trying to find one that does rely on the interface. So I can provide here my users repository and here. So at runtime, because we're coding to abstractions, we could provide different implementations. So I can switch from SQL Server to NoSQL and provide a NoSQL concrete repository. I can provide a mock so that I can do unit testing. And at this level, this one because it's easier. At this level here, services, it don't care how it's saved. It just because I have my different implementations, so I can call this without worrying how it's saved. And thanks to the separation of concerns, I was able to add new features like adding permissions in. Application roles without rewriting any the core package login code, which is a different API. So that's the end of the demo. With DD as an approach, DDD, sorry, as an approach, I can focus on my core business domain and build my software around that, because it's about more than just code. It encourages developers to work closely with the domain experts, in my case, the stakeholders and the concierge staff, to make sure the system reflects the real-world processes. I can divide the system into different contexts or modules, like residents, packages, concierge, sites. Each part of the system has its own clear boundaries, which keeps things modular and scalable. Lastly, one of the biggest challenges in software projects is communication. Developers, stakeholders, and end users often have different ways of describing the same thing. with ubiquitous language. Everyone, no matter if it's a developer, a concierge, or a property manager, uses the same terminology. This reduces confusion and ensures that what we build aligns with real world needs. If you found any of this helpful, please make sure to subscribe so you don't miss the next video, where I'll continue breaking down how I built the beginnings on my SaaS platform. And if you have any questions, or want me to dive deeper into a specific part of the architecture, drop a comment below. Thank you.